Good morning, my dear students. Today we are going to discuss about some different models in complex numbers and De Moivre's theorem. Okay. So let us now the first one. Alpha, beta, gamma are the roots of x cube minus 3x square plus 3x plus 7 equal to 0. And omega is the cube root of unity. Then the value of alpha power minus 1 by beta power minus 1 plus beta power minus 1 by gamma power minus 1 plus gamma power minus 1 by gamma minus 1 by alpha minus 1. Alpha minus 1 by beta minus 1 similarly remaining. So now students, is there what is the given equation? X cube minus 3x square plus 3x plus 7 equal to 0. Now this is the students x cube minus 3x square plus 3x equal to minus 7. Now students, this is x cube minus 3x square plus 3x. We are taking minus 1 on both sides. So this is the formula of x minus 1 whole cube. What is the students? This is the formula of x minus 1 whole cube. After then student, this is minus of 8. Minus 8. Now students, now we can written as x minus 1 equal to, this is the students x minus 1 whole cube equal to minus 2 whole cube. Now students, cube is sending to the other side. We can written as the x minus 1 equal to minus 2 into cube root of 1. So the cube is sending other side, cube root 3 cancel. The cube root of 1 are 1 comma omega square. So students, what we observed here, alpha, beta, gamma are the roots of, that is alpha x equal to, substituting x equal to first alpha minus 1 is the minus 2. After then students, substituting x equal to beta minus 1 equal to students minus 2 omega. After then students, we are taking gamma is the root, that is gamma minus 1 equal to minus 2 omega square. So students, now we have to find the value of, what is the students? The value of alpha minus 1 upon beta minus 1 plus beta minus 1 by gamma minus 1 by alpha minus 1. So students, this is alpha minus 1 by beta minus 1 is the 1 by omega. After that student, this is 1 by omega. After that, this is also students 1 by omega. How to write the students? First alpha minus 1 by beta minus 1. After that students, beta minus 1 by gamma minus 1. After that students, this 1 by this is the students omega square. Now students, this is we can written as 2 by omega plus omega square. Now students, how can you write this is omega square, also we can written as 1 by omega. Since numerator and denominator we have to multiple with omega. Omega square into omega is the omega cube. So students, omega cube is the 1. So this is the students 3 by omega or 3 omega square. This is the solution. 3 by omega or, what is the students? 3 by omega, 2 plus 1 3 by omega or 3 omega square. Numerator and denominator we have to multiple with omega square. Omega into omega square is the omega cube. Is it clear students? So when alpha, beta, gamma are the roots of that equation, first we are taking minus 1 on both sides. This is minus 8, minus 2 whole cube. Therefore, x minus 1 equal to minus 2 into cube root of unity r 1 omega square. Therefore, this is x minus 1 is the minus 2 omega square. Okay, students, these are the values of alpha minus 1, comma beta minus 1, comma gamma minus 1 respectively. Okay. So students, alpha, beta, gamma are the cube root of unity. Okay students, then the value of x alpha plus y beta plus z gamma by x beta plus y gamma plus z alpha. So students, alpha, beta, gamma are the cube root of unity. That means let alpha equal to 1, beta equal to omega and gamma equal to omega square. Now students, is there x alpha, y beta, z gamma by x beta, y gamma, z alpha. Now this is the students x plus beta is the omega. This is omega square upon beta is the omega, gamma is the omega square and alpha is the 1. Okay students, right now students, so here the x plus y omega z omega square by omega is the common in the denominator. So students, when we are taking the omega is the common, that is x into omega, x omega. After that students, omega into omega, omega square. Now students, z into omega square. Omega into omega square is the omega cube. Omega cube is the one we got z. So students, what we observed, when we are taking the omega is the common, that is x omega, omega into omega, omega square into omega is the omega cube, that will be 1, that is z. So we observed here the numerator and denominator are equal. So what is the remaining? 1 by omega. What is the students? 1 by omega. So we have to multiply with the numerator and denominator omega square. So this is omega square by omega cube. So student, this is also omega square is the answer. Okay students. Now students, the question number 3. The number of common roots of the equation. The number of common roots of the equations x cube plus 2x square, 2x plus 1 equal to 0 and x power 2012, 2014 plus 1 equal to 0. So dear students, right now we have to find the number of common roots. So students, what we observed, the students, the first equation of the degree 3, it has three roots. What is the students? It has three roots. Here the highest power is 2014. It has 2014 roots. So in which how many are the common roots? So students, what we observed here, when we are taking x equal to -1, this is -1 plus 1 cancel, plus 2 and -2 cancel. By the trial and error, we observed here the -1 is the one of the root. What is the students? When we are taking -1, x is a -1. By Horner division, 1, 2, 2, 1. This is 0 students, 1. So this is -1. Now student, this is 1. 1 into -1, -1. So students, then it will be the x square plus x plus 1. So this is the constant term, x term and x square term. X square plus x plus 1 equal to 0. Okay students, now this is x square plus x plus 1 equal to 0. So my dear students, we have to know that the roots are -1 plus or minus root 3 I by 2. So dear students, here the x is the omega and omega square. What is the students? X equal to omega and omega square. So when we taking x equal to -1, here this is +1, this is +1, this is +1, does not satisfy. So dear students, when we are taking the omega, this is the students, substituting x equal to omega in this, omega power 2012, omega power 2014 plus 1. So dear students, we have to know that 2012 with divided with 3. So 3 6 are 18. Now this is 3 7s is that 21. Okay students. So is there 2? My dear students, how can you write the students? So this is the students, what we observed, this is omega cube whole power 6, okay students, into omega square. So this is 0, this is 21, yes, omega square. After that students, how can you write this is? Undoubtedly students, so we can written as this is, see, omega cube whole power 6071. So into omega. Are you understand students? Are you understand? This is 1. So omega square plus omega plus 1. Everybody know that 0. Similarly students, when we are taking x equal to omega square, undoubtedly students, we got, when we are taking x equal to omega, it will be satisfied. Undoubtedly students, when we are taking x equal to omega square also, we got omega power omega square whole power 2012 omega square 2014 plus 1 also we got 0. So students, the number of common roots are omega and omega square, omega and omega square. So there are 2 common roots. The number of common roots of the given equations are only 2 common roots. Those are omega and omega square. Omega and omega square. Okay students? Alpha equal to -1 plus I root 3 and n is positive integer, n is a positive integer, n is a positive integer which is not a multiple of 3. Which is not a multiple of 3. Which is not a multiple of 3. Then the value of alpha power 2n plus 2 power n into alpha power n plus 2 power 2n. Dear students, n is a positive integer which is not a multiple of 3. So students, what we are taking here? So what we observed, if n equal to 1, so dear students, first the alpha is given that, what is the students alpha is? Minus 1 plus I into root 3. What is the students alpha? Minus 1 plus I into root 3. So students, divided by 2 on both sides, alpha by 2. Minus 1 plus I into root 3 by 2. So this is, we know that, my dear student, this is omega. Alpha by 2 is nothing but omega. So dear students, n is a positive integer which is not a multiple of 3. That means if n equal to 1, that implies this is alpha square 2 power 1 alpha and 2 square. This is the students, what is the alpha is? Alpha is the students 2 omega. 2 omega whole square. 2 into alpha is nothing but 2 omega. 2 omega. So this is the 4. Now students, 4 omega square, 4 omega plus 4. 4 is the common. So omega square plus omega plus 1. This is the students 1 plus omega square value is the 0. Now its solution is the 0. Okay students, its solution is 0. Okay students, now the next one students, if alpha is a non-real fifth root of 1, is a non-real fifth root of 1, fifth root of 1, then logarithm of 2, 1 plus alpha, alpha square, alpha cube, minus 1 by alpha. Okay students, in modulus. So dear students, how to write this is the students, is given that alpha is a non-real fifth root of unity. So dear students, when we are taking here alpha be the fifth root of unity, so fifth root of unity, when we are taking power 5 on both sides, alpha power 5 equal to 1. So student, this will be sending other side, 1 minus alpha power 5 equal to 0. We know that 1 square minus x square is 1 minus x into 1 plus x. 1 cube minus x cube is 1 minus x into, how to write this is a minus b into a square plus ab plus b square. Similarly students, what we written as this one, the 1 minus x into 1 plus x square plus x cube. Dear students, a square minus b square is, how can you write 1 minus x into 1 plus x? When it is cube is there, we can written as up to 2. When it is a power 4 is there, we can written as up to cube. Now students, we can written as here the 1 minus alpha power 5 is, how can you write this is the students, 1 minus alpha into 1 plus alpha square alpha cube alpha power 4 equal to 0. So students, what we observed here, so the alpha equal to 1 and after that 1 plus alpha square alpha cube alpha power 4 is given that one condition is given that alpha is the non-real root. That means undoubtedly 1 plus alpha square plus alpha cube plus alpha power 4 is the 0. So students, how can you find this one? The logarithm of 2 into 1 plus alpha square plus alpha cube. The numerator and the denominator we have to multiply with alpha power 4. So dear student, this is alpha power 4, this is the alpha power 5 in modulus. So students, how can you write this is the students, 1 plus alpha square plus alpha cube. This is the minus of alpha power 4. So logarithm of this will be the students minus alpha power 4 upon the alpha power 5 is the 1. So this is 1. Now students, is there base 2. Now we can written as logarithm of base 2 minus alpha power 4 is the minus 2 alpha power 4 in modulus. Now this is the students, we can written as log mod of 2 alpha power 4. So dear students, when we are taking alpha square alpha cube alpha power 4, in particular mod undoubtedly 1. Suppose students, we have to know that 1 omega square are the cube root of unity. The mod of 1 is 1, mod of omega is also 1, mod of omega square is also 1. So these are all fifth root of unity means, so the modulus must be equal to 1. Since the omega we have to know that minus 1 plus root 3 I by 2. This is when we are taking the mod 1 by 4. This is the 3 by 4. So students, 4 by 4 undoubtedly it will be 1. So similarly here what we observed here, the alpha modulus of alpha power 4 is must be mod alpha square, mod alpha cube, mod alpha power 4. Each and every one modulus is the 1. So students, log 2 base 2. What is there here? What is the remaining? Logarithm of ln 2 log 2 base 2. Then it will be 1. Okay students, what we get here? This is 1. How to write first one? So first we have to multiply with alpha power 4. This is alpha power 5. This value is 1. We have to know that alpha we are taking fifth root of unity. Now we are applying on both sides power 5. So that is 1 minus of, how to write this is 1 minus of alpha power 5. This is a minus b into 1 plus alpha square alpha cube alpha power 5. When we have to multiply with 1 and minus alpha, we got this one only. So after that student, this is the second factor equal to 0. Since alpha is a non-real root, alpha is the students non-real root. So that's why we are taking this will be the 0. So after that students, this is also equal to minus of alpha power 4 minus 2 alpha power 4. In modulus minus 2 is the plus. The modulus of alpha power 4 is the 1. Log 2 base 2 is the 1. Okay students. Now students, the another one, if cos x 2 cos y, after then 3 cos of z equal to 0, that equal to sin x 2 sin y 3 sin z, then the value of dear students, the sine of 3x 8 sin 3y 27 sin 3z, 27 sin 3z equal to, okay students, this is also one more objective question students. So already I completed cos x, I was completed cos x cos y plus cos z 0, and sin x plus sin y plus sin z is 0. So students, here how to take, let alpha equal to 6x, beta is the students 2 into 6y, gamma is the students 3 into 6z. What is the students 6x? Cos x plus I sin x. What is the 6y? Cos y plus I sin y. What is the 6z? Cos z plus I sin z. So students, here alpha plus beta plus gamma, when we are taking sum of these three, cos x plus 2 cos y plus 3 cos z, it will be 0. I is the common sin x, 2 sin y plus 3 sin z, it will be also 0. So when alpha plus beta plus gamma is 0, we have to know that, if x plus y plus z 0, then it is, we know that alpha cube, beta cube, gamma cube equal to 3 alpha beta gamma. When alpha plus beta plus gamma is 0, we have to know that a cube plus b cube plus c cube equal to 3abc. So what is alpha? 6 cube x. What is the beta? 2 into 6y whole cube. What is the gamma is there? 3 into, dear students, 3 into 6z whole cube. So 3 into alpha is the 6x. What is the students? Alpha is the 6x. Beta is the students 2 into 6y, 3 into 6z. Now student, this is 6 of 3x. So now this is the students 2 cube is the 8. 6 of 3 into y, 3y. After that students, we can written as this is 27, 6 of 3 into z, 3z. 3 3s are 9, 9 2s are 18, 6 of x plus y plus z. So our required one is equating the sin 3x is there, sin 3y is there, equating the imaginary parts on both sides. My dear students, equating imaginary. Equating on both sides, imaginary parts on both sides. Equating the imaginary parts on both sides. Here the imaginary part is sin 3x. Is there 8 sin 3y? Is the imaginary part is here 27 sin of 3z equal to students 8 into sin of x plus y plus z. What is the students? This is the solution. Sin 3x, 8 sin 3y, 27 sin 3z is the students 18 into sin of x plus y plus z. Okay students? Dear students, if 1 comma alpha 1 comma alpha 2 and so on alpha 19 are the roots of z power 99 minus 1. So dear students, how can you write this is? Suppose students 1 comma 2 are the roots of x square minus 3x plus 2. How can you write this is the students? The x square minus 3x plus 2 can be written as x minus 1 into x minus 2. When we have to multiple with this one, x square minus 3x plus 2. That is the meaning of 1 and 2 are the roots of 1 and 2 are the roots of the equation x square minus 3x plus 2. Similarly students, we can written as the z power 100 minus 1 equal to x minus 1 into x minus alpha 1, x minus alpha 2 and so on x minus alpha 99. So dear students, what are the roots are here? 1 alpha 1 alpha 2. Sum of the roots. Sum of the roots. How to write the students? 1 plus alpha 1 plus alpha 2 and so on. And so on students. 1 plus alpha 1 plus alpha 2 and so on. What is the students? Up to alpha 19 is the students here minus a1 by a0. Second term is not there, z power 99. So student, this is minus of a1 by a0, then it will be 0. Since z power 99 term is not there, so 0 by 1, that is 0. So students, now sum of the product of the roots, sum of the product of the roots taken 2 at a time. Sum of the product of the roots taken 2 at a time. 2 at a time. Dear students, 1 into alpha 1, alpha 1, 1 into alpha 2, alpha 2. Similarly, after that alpha 1, alpha 2, alpha 2, alpha 3. So students, that is nothing but sigma is there. Sigma alpha I, alpha z, where I, what is there students? 1 less than or equal to I less than j less than 99. What is the students? Plus is there alpha 1 plus alpha 2 plus alpha 3 and so on alpha 99 is given that 0. How to write the students? Sum of the product of the roots taken 2 at a time, that is 1 into alpha 1, 1 into alpha 2 and so on 1 into alpha 9 plus alpha 1, alpha 2, alpha 1, alpha 3, that is the sigma alpha I, alpha z, where I and z in between 1 to 99, it will be also 0 since a2 by a0. So here is not there z power 99, z power 99, after the z power 98 terms are not there, that is 0 by 1, that is also 0. Now students, they are asking sigma alpha I, alpha z. So that is sigma alpha I, alpha z, 1 less than or equal to I less than j less than or equal to 99. This will be, we know that students, what is this value is? This value is the students, the plus 1 is sending other side, minus 1 equal to 0. So student, the required solution is alpha I, alpha z, 1 less than or equal to I less than or equal to j less than or equal to 99. It will be minus 1 is sending other side, plus 1. Minus 1 is the student sending other side, plus 1. Okay students? Now the another question is the students. if a plus ib whole power 5, a plus ib whole power 5 equal to alpha plus I beta, then b plus ia whole power 5 is equal to b plus ia whole power 5 equal to. So dear students, what we find right now, the b plus ia whole power 5. So my dear students, is there, when we can take it here, I is the common, b minus ia whole power 5. What is the students? B minus, what we observed here, 1 minute student, this is the IB, this is the I square is the minus 1. So undoubtedly students, I square is the minus 1, minus half, minus plus. So student, this is the whole power 5, this is also whole power 5, is there alpha plus I beta. Okay students, now this is the students, we can take an as b I min whole power 5 equal to, dear students, is there alpha plus I beta by I power 5 is the students, I power 5, everybody know that I power 5 is the only I power 4, I square whole square into I, this is nothing but I. So students, this is I. So b minus ia whole power 5 equal to, what is the students, alpha plus I beta into I by I. This is the students, what happened here, here what we observed here, this is alpha into I, alpha I minus of beta upon minus 1. So dear students, what we are taking here, what we observed here, so first we are taking here into I by I. So first I power 5 is sending other side by I power 5, I power 5 is the I, after that we are taking into I by I. This is the students, I into I is the I square is the minus of beta, this is alpha I, upon I square is the minus 1. So student, this is beta minus of alpha I. What is the students? Beta minus of alpha I. Is it clear students? Now what is the conjugate of this one? Beta plus ia whole power 5 is the students beta plus alpha I. Okay students, beta plus alpha I. So dear students, modulus of z plus 16 equal to 4 into z plus 1, then mod z equal to, so when we are squaring on both sides, z plus 16 whole square equal to 16 into z plus 1 whole square. So this is the students, we can written as z plus 16 into z bar plus 16. This is we can written as the students z plus 1 into z bar plus 1. So now the multiplication is the students, we have to first multiply with z bar, z bar 16 z bar. After that students, 16z plus 256, 16 into This is the students z bar. After then z plus z bar plus 1. So dear students, we can written as this is z bar 16z bar 16z. This is the 256 16z bar 16z bar plus 16. These two are cancelled. Now students, when it is sending to the other side, 15zz bar equal to students 256 minus of 16. This is the students 240. The z bar is nothing but mod z square. This is the students mod z square by equal to 240 by 15. 15 1 jar, 15 6 jar. So students, the value of mod z equal to 4. Write down students, the value of mod z is the 4. The value of the mod z is the 4. Write down. Now students, if mod z equal to 1 and w equal to z minus 1 by z plus 1, then the real part of w. So dear students, is not given that omega. When it is given that omega, undoubtedly cube root of unity also given that. What is the students? When you can read as omega, undoubtedly the question undoubtedly they are given by omega is the cube root of unity. What is given that? When it is given that omega is the cube root of unity, then the mod omega must be 1. Are you clear? When it is given that omega is the cube root of unity, then you can written as mod omega is the 1. But here the mod z is 1. So students, here we are taking, first you have to multiply with z w plus w equal to z minus 1. So z is the common. Is there omega plus 1? How to write the students? How to write this is, what is the common? Z is the common. Omega minus 1. These two are sending other side. Minus omega. Therefore students, the z equal to minus 1 minus omega by 1 minus omega. So students, the minus is sending to the other side. 1 plus omega by 1 minus omega. So students, what we observed here, taking modulus on both sides, 1 plus omega by 1 minus omega. This is, we know that mod omega is given by 1. So students, this is 1 plus omega, 1 minus omega. What happened here? The 1 plus omega equal to 1 minus omega. Suppose students, what is the real part of omega? Let w, we are taking some x plus iy. Undoubtedly its modulus is 1 plus x plus iy. This is 1 minus of x minus of iy. How to write the student? This is the square root of, what is the modulus? Square root of 1 plus x whole square. Square root of, dear students, its modulus is 1 plus x whole square plus y square. This is the students, the 1 minus of x whole square plus minus y square is the plus. When we can squaring on both sides, a square b square, and is there only the 4x will be 0, x equal to 0. X is the students real part of w, therefore the real part of x is nothing but real part of w is the 0. The real part of w, the x is real part, y is imaginary part of w. So the real part of w is the x. We got 0. Okay students. Okay students, write down. Okay student, this is today. All of you practice these questions. Okay students, thank you all.